right, so that was just an example of another type of a reaction called a condensation reaction for building long polymers. And in this particular case, two different monomer units were used, one with alcohol functional groups, one with carboxylic acid functional groups, to form a copolymer called P. All right, here's a question for you. You've seen terephthalic acid and ethylene glycol can react in the previous slide. Now consider acetic acid and ethyl alcohol. Okay, this is acetic acid right here, little carboxylic acid group, and ethyl alcohol or ethanol is a simple alcohol with one hydroxyl group. So show how this carboxylic acid and alcohol can react to form an ester, and then could acetic acid and ethanol react to form a polyester? So you want to explain the reasoning. First of all, we want to show how the two individual monomer units can form, or the two individual molecules can form an ester. So I'll write down the acetic acid. I'm not going to put the hydrogens on because it makes it so messy. There's the acetic acid plus the ethanol. Okay. And you know that the hydrogen from the alcohol group and the OH from the carboxylic acid group are going to split off to form water, leaving this oxygen to bind directly to that carbon, giving us our ester linkage. So I'll just write that molecule over here. It's going to be C. Okay, so that's the molecule that we form, and you can see the ester linkage is right here. Now the question is, could acetic acid, this is acetic acid, and ethanol react to form a polyester? And explain. Well, once you react this acetic acid and this ethanol, then the only functional group you have is the ester. There's no leftover carboxylic acid or alcohol group to react again to keep this reaction going, as in like a chain reaction situation. So the answer there for part B is no, because there's only one functional group on each of these monomer units. In order to make it work, you'd have to have two functional groups on the monomer, not just one. Okay, so that's the difference. One of the differences between a condensation reaction and an addition reaction. The addition reaction, since you're just adding, you're just breaking that double bond, then you don't have to have functional groups. You just have to have the double bond. Whereas with this, you have to have the alcohol and carboxylic acid functional group for this particular type of polyester. Okay. The next question to consider is this one. I accidentally wrote on this one. Is in both PET and PEN, the alcohol monomer is ethylene glycol, but the organic acid monomers differ slightly. Here's the organic acid monomer in PEN. Okay. Use structural formulas to show the reaction of the two molecules of naphthalic acid with two molecules of ethylene glycol. Okay, so I'll just use this paper right here to answer that question. All right, so we want to see two molecules of naphthalic acid, that's this right here, and two molecules of ethylene glycol. So the first one, if we write down OHCO, this is naphthalic acid. Naphthalene is two benzene rings stuck together. That's what is mothballs or naphthalene. But if you add the functional groups, then it becomes an acid. There's one of them, plus the ethylene glycol is OH, and then H is here. So you see there's two functional groups on this molecule and two functional groups on this. So the first reaction is going to be between the hydrogen and the OH here. Okay, and then if you add another one, acid is going to be the acid group, then the naphthalene, okay, so this is going to join up right here to give another split off of water. This is going to split off water. This is going to split off water, and we'll have this ester here, And then if we add one more alcohol group, then this H and that OH will split off. This O will hook up with that, and that will be 1, 2, 3, 4 units. That's what it would look like. So you can try to redraw that. That's kind of a mess there, but I'd like for you to try to redraw that without the waters and see if you can draw a nice little polymer with 2 of the acid groups and 2 of the alcohol groups. Okay, so you just know that it's the OH from the carboxylic acid that splits off with the hydrogen from the alcohol group, and then this CO is going to connect right up with that C double bond O to give your ester. See if you can do that. Okay, and let me see if there's one more slide here. Okay, and then the last thing I want you to do is now just reading your book, there's a section on polyamides. Polyamides, the formation of polyamide occurs by a condensation reaction as well. And so I'd like for you to read about that in your book. And this question isn't good. It says, why is it a copolymer? I meant to say, why is nylon a copolymer? So you want to answer that question. Why is nylon considered a copolymer? Draw the basic reaction, and then suggest why the properties of synthetic polyamide nylon is similar to the function to a natural polyamide silk, and explain why that's an example of structure-function relationship. So this is just to help guide reading you, or help you to guide your reading through the section on polyamides. But I just want to point out that polyamide is also, the formation of polyamide occurs by a condensation reaction as well. And it's just at the end of the condensation reaction, instead of having an ester, you have an amide functional group. And remember, the amide functional group is when you have an C double bond O bound to a nitrogen. So it's an amine connecting with a carboxylic acid, splitting off water to give this amide functional linkage. So I'd like for you to just take your time and go through taking a close look at nylon and see how it is similar to silk.